Hi, we are in the midst of talking about equilibrium, and we're about ready to set up an equilibrium constant expression. Remember, expressions are symbolic. And symbols have meaning. So you have to write symbols as they are required. For example, those brackets are considered molarity. You can't use parentheses in the expression. You can use parentheses in the mathematics, but not in the expression. Now, when we set up our equilibrium constant, we do not include solids or pure liquids, such as water will be the most common one, because they don't really have a concentration per se, a molarity per se. The states that we always include are gaseous and aqueous. Now, we do not in PreAP and AP use units for KEQ. IB has used units before. I've seen test questions with units, but for now we're going to consider them to be unitless. If you did need units, all you have to do is kind of cancel out what's in the numerator and the denominator and write down what remains. So it's not a big deal to pick up when you get into IB if you do that. Now, the value is a constant unless we change the temperature. Okay? So it's common to report the temperature because it changes with temperature. So if you're going to report a value, we want to be politically correct, so to speak, and list the temperature at which it was measured. But we won't be putting temperatures into the mathematics of these. So sometimes those numbers can be distracting. So we want to write the expressions for each of these. And the first thing we want to do is check the states. Now, these are all gases, and since they are all gases, we will include them all in the expression. So I recommend doing that, going through the states and checking off what you would include and what you wouldn't include. So we put the products on top, so it's carbon monoxide. Now, there is an implied 1 in front, and there would be an implied 1 there. We wouldn't normally write it. I would not take off credit if you did write it, but it's not normally needed. Now, that 3 goes as the superscript there. The 3 from the coefficient becomes the superscript, not multiplied, superscript. And remember, we're multiplying here. We are not adding and subtracting. It's the products. The product of the products on top, the products of the reactants on bottom. Now, since water is a gas, we do include that, and that would be our KEQ expression. Let's try the next one. Check your states. They're all gases, so we include them all. So our K equilibrium will equal, and we put a line there. Now we put our products on top, which is ammonia, right? It's an expression with symbols. So we put ammonia, and then we're going to raise it to the power of its coefficient over nitrogen. Now remember, it's multiplied, not added. So H2, and then we raise it to the power of the coefficient, and that's in front there. All right, let's try the next one. Now, we have a solid. That does not go in the expression. This AQ does, and this AQ. This is KEQ. It actually has, we start to see where ultimately you put little different subscripts as the equilibrium changes, but I'm not going to test you on that right now. I just wanted you to know that. We have silver ion squared times chromate to the first. Now notice there's nothing in the denominator, and that's okay. If you want to put a 1 there, you can, if that makes you feel better. I usually don't. I usually just leave it as is. There is nothing in the denominator for this one. All right, we have a gas, we have a solid, we have a gas. So KEQ will equal my product on top always, squared because of the balancing coefficient, over H2. I do not put the I2 in the expression. Okay, Now this next one, pure liquid, aqueous, and aqueous. All right. This is a special one, and you saw this in acids and bases. This is where we get that Kw, remember Kw was 1 times 10 to the minus 14th. Well, that's equal to our H3O, aka H+, times our hydroxide. So that's how we set up these expressions. Let's take a look. We're going to do 2 quick examples here. Whenever we do this, you always set up the expression without numbers first. So it's NF, if I can write here and talk at the same time, it's NF2 gas squared over N2F4. And the question says calculate the equilibrium constant. So this is my unknown. It gives me this concentration as 0.9989, and it gives me this one as 1.131 times 10 to the minus 3rd. So KEQ is 1.131 times 10 to the minus 3rd squared over 0.9989. If you crank out that algebra, and I'm going to take it to 4 sig figs, I get 1.281 times 10 to the minus 6. Then we don't have to worry about units. Kind of sweet. Okay, let's take care of the next one. Let's see what we would put in it. That's a gas, that's a gas, that's a gas. So we're going to include all of those. So we'd get NO to the 4th over N2O squared times O2. Now, this time we are given KEQ, and we're given, so let's check what we're given. We're given this, we're given the N2O, and we're given the NO, or excuse me, we're asked for the NO, and we're given the O2. So let's plug in 1.7 times 10 to the minus 13th is equal to x to the 4th. So you're going to need to find that math that usually looks something like that, the x root of the number, and you'd put in 4 and then this symbol and then put whatever is on this other side. So if you need help with your calculators on that, let me know and I'll show you where that is in class. Okay, so I plugged in everything. If I solve for my unknown, you really, really, really want to try this. And make sure you get 5.56 times 10 to the minus 9th. Now, we solve for a concentration, and remember those brackets mean molarity. So you want to put that unit afterwards. Okay, we have a couple more things to do, and there's a next step of how to solve these equilibria. So until the next movie when we attack those, this is signing off.